Alright, so let's move into doing some underground conduit with large radius sweeps. Now, in general, for routing conduit over large distances, it helps to have at least three views open. You want a section view, uh, two section views really, two orthogonal section views to give you um, X, Y, and Z routing. You also want a three-dimensional view open to be able to take a look at how your conduit route is progressing, and then a planned view. This is not the planned view. We want a planned view. No, there's the planned view. So a planned view, two orthogonal views. Be able to see the conduit routes. Before we get too far into this, let's let's place a target for our conduit route. We'll go here to families, and let's see if we have the precast pull box in our template model. It would be under electrical equipment, and I don't see it here. So let's go ahead and add that. So insert load a family, and under the electrical families we have precast concrete fixtures. We'll get a resizable handhold. And we're going to go ahead and place that in our model. It's electrical equipment. And let's make it a 3x4x5. So go here to the type. We're going to change this one to a 3x4x5 box. So make it 3 inches wide by, or rather 3 feet wide by 4 feet long by 5. No. It's 4 inches wide, 5 feet long, 3 feet deep. And it's a precast communication handhold, 3x4, rather 48 by 60 by 36 inches deep. We'll keep the traffic rated lid. We'll just assume that we can find this in a catalog later. We don't have a part number for it yet. And while we're looking at that, we want to make sure that it is actually, if we look here in the 3D view, it's actually submerged beneath the ground a little bit. So you go to our plan view. Let's move our section view over. That's our working section view. And we can take a look at the actual location of the handhold. You can see that it is submerged beneath the surface. So bring that up just a little bit. And there you go, you can see it now. And usually in the real world you're going to have 3 to 6 inches above finished grade for the upper lid. So you can select that item, dimension it, and then just tell it that you want it 3 inches. You want the upper lip 3 inches above the surrounding surface. And then it'll move that for you. So that's going to be our target. We'll assume that's a comm pull box. For the sake of argument, we'll assume that we're pulling fiber from this wireway, and our fiber optic group has specified that they want 36-inch sweeps for all conduits containing their fiber, the conductors. So in order to do that, we need to create a conduit type that uses 36-inch sweeps. So there's a couple of ways to do that. We have some fixed sweep elbows, which you can use to specify exact angles and exact sweep dimensions, and even the conduit straight sections that are on the end of those sweeps. This would be catalog information. Problem with this is you have to use exact angles for the fitting. They're not resizable. Another solution, probably an easier solution, is if you go to Manage, MEP Settings, Electrical Settings, or you can just push the ES keys. We've created some size standards within the electrical settings. Basically what it does is it takes the sizes of the conduits and it forces all of the minimum bend radius to be 24 inches. So regardless of the actual radius of your turn, it will force that radius to be at least 40 inches. You can make it larger, but you can never make it smaller. So that's what we're going to do. We're going to use a conduit type that uses that size standard for making the bend. So we'll just pick a, it looks like there's already been one created here, a PVC 40 for underground conduit with a 36-inch resizable sweep. And if we take a look at that definition, look at the type properties. There we go. Look at the type properties. You can see that it's the standard that it's using is this 36-inch sweep standard. So it's using the galvanized rigid sizing, which is the same as PVC 40 essentially, and forces the sweep to be 36 inches. And the type comment is set to PVC 40. It's using the GRC elbow, which is what we expect for underground. Really, we could get rid of these T's and because we're not going to use any in underground, but we'll leave them in as is for now. And we'll just go ahead and start drawing some conduit. So draw the conduit from the face. And let's move this connector over to one side a little bit. We'll say we want 3 conduits coming out of here. Let's do 2 3-inch conduits. So we'll start one and then we'll try to duplicate it. Make sure that we're in the right conduit type, that we're using the resizable 38 6-inch sweep. That we've got a diameter of 3 inches. And it's coming down out of the box. You can see here we're outside the crop region, so let's extend the crop region out a little bit so we can see a little better. So we've dropped the conduit down. Now we need to switch to one of the other views in order to create the sweep. And note that because we're using the 36-inch sweep sizing standard, it automatically gives us a radius 36-inch bend. Let's draw this, extend this out. And if we switch to the plan view, we can make sure that we extend the clip region so we can see our target box. There it is. So, and if you want to adjust the angle, that's, of course you could do that, because this is a resizable elbow, so it will let you change the angle. So we're going to come to about there. We'll let's switch this to wireframe so we can see through the ground. Or rather, not wireframe. Wireframe's fine. It's the view range that's killing us here. So get unlimited view range. There we go. Now we can see the conduit. We'll draw this conduit. You could try to connect it here. Let's see what happens. find a solution on its own, probably because the sweeps are so large. If we move it out just for the sake of argument, that's not where it's actually going to be placed, but let's see if Revit can come up with a solution. Oh, and that time it was able to come up with a solution. Let's take a look at a 3D view, see what kind of solution it came up with. Let's go ahead and turn off the topography. And then we'll extend this section view, this section box, so that we can see our conduit. That's not too bad. You'll notice that it came up with the bends and the straight sections all on its own. Let's see if we can reposition that box. No. Sometimes you can select enough of the fittings and then try to move the whole assembly. Revit is a little more forgiving that way. Yeah, there you go. So we're bending it, we're moving it based on this, we're resizing just this one small section of conduit. We're telling it to keep all this the same, and we're just going to move it along this little axis here. So there's our 36-inch sweep, and let's use the parallel conduits tool to duplicate this run. So if you hover over and then tab the entire run, you can sometimes get all the conduits that are associated with that run, which is not what we want here. So to unselect them, we'll hold select, hold down the shift button rather, and then unselect everything that isn't a conduit, or unselect all the conduits we don't want, and then we'll filter out things that are not conduits. And now that we have just this conduit run that we're interested in selected, we can go to parallel conduits. And if we look at our minimum raceway spacing for 3-inch versus 3-inch conduits, the minimum spacing between each conduit is 4.5 inches. So we'll do an offset, a horizontal, and a horizontal offset of 4.5 inches should be fine. This horizontal vertical offset changes based on where you place the conduit. So we got one there, one there. You can try doing this one here, and we'll only let you offset the straight sections, and then you just have to go back. You can try doing the whole run. Sometimes that works, sometimes it doesn't. For instance, if we tried to select all this conduit here, and then told it we want to parallel may let us, it may not. Go ahead and turn off the architectural view, get that stuff out of the way. And we'll hide everything except the conduit that we're looking at. Let's see if we can get this to work. Working with the parallel conduit sometimes is more hassle than it's worth, but you get a nice model. So we can select the entire chain here by hovering. Let's see what that does. Oh, there you go. So just to redo that, system, parallel conduits, hover and select once you determine the offset that you want. And now it's going to parallel all those highlighted conduits, and there it went. You've got now a 2 conduit run. If we wanted to do, let's say we wanted to stack 2 by 2 stack, you can do that as well. And if we there's actually not enough room for that, but as you can see here, the conduits on the vertical section weren't able to connect, but you can see what a nice conduit duct bank it is able to create if you've set your initial connections properly. But we'll go ahead, we were only planning to do 2 conduits. So that works out just fine. We got 2 conduit route, and now let's go ahead and number these conduits. Make sure that so you can tab it. We'll try to select everything that's connected, but we only want one of these conduits to have the number. So shift and click to unselect the conduits that we don't want numbered, and then we're going to apply the conduit number to those. We're going to call that C101. This one is going to be C102. Did it renumber these conduits when I was working? No. Okay, so we're good. Okay, so now we've got conduits, and we've got numbers selected for numbers input for the conduits. It's important during the modeling phase to make sure that you have at least the conduit number applied. And as you go through and do the schedule filters all the conduits based on the conduit number you've selected in the model. So if you have failed to number conduits, you'll get a blank space in your conduit schedule, and you won't be able to schedule anything. So you have to at least set the conduit number. Let's go back and we'll turn the other links back on. We will hide the objects that we had temporarily hidden. And now let's go ahead and try to schedule our equipment, or rather schedule our conduit.